Let me explain the concept of recursion. So what is a recursive function? What is recursive function and how it executes? Because in binary search tree, we have printed all the node information using the concepts called recursion. Using recursion. Say recursion means the function calling itself is called recursion. Simply to say, calling the function from the definition of same function. Calling the function from the definition of same function is called recursive function. Let me explain with the simple example how that program gets executed, and the same thing I'll explain using in order, pre-order, post-order also. Hello. Right. So here it is. So whenever we are writing the function, suppose, let me explain with the simple example. Let me explain with the simple example. Here it is a program execution automatically starts from the main. Start from the main. From the main, I'm just calling one method. A simple method I'm calling. Method name is ABC. ABC. Just with the simple example, giving that message is a start. How to call this method using the class name or same class directly also you can call. Static method or using the class name. When you are executing this, output is just a message is a start message will print. Is a start. One more statement we are writing. One more statement, just end we are writing. Then output will be start and end. Recursive function means, look at this. From this function, we are calling the same function. We are calling the same function. See, so whenever we are executing this one, infinite times it is executing. Only start. Finally, it is saying that memory is a full. So why? Because here it is. First ABC function execution. ABC will start. Inside the first start message is printing. After that, again we are calling ABC. What will happen here? Again it will allocate the memory for this ABC. Again it will call. This is a start. Again we are calling that ABC. There is no chance to complete the execution. Again we are calling that ABC. Is keep on calling. Always allocate the memory. Always allocate the memory for this ABC only. And is calling continuously like this. ABC. And is a start. So whenever it reaches a particular location, finally, suppose this is the memory allocated to this program. So now it is end. Now it is end. So here it is giving that error is a memory full. Memory is a full. But sir, how can we execute recursive functions? Means the way we need to write the code, it should come back and where it has started, there it will complete the code. In such a way, we are writing the code. How can we? So one simple example, I'm just passing the value 3 that we are collecting into one variable. Here printing that x value, printing that x value, here also printing that x value until if x value is greater than 1, we are calling ABC of x minus 1. See, just consider is only one line of code. See how this code gets executed. It is also recursion. See, calling the function from the same function. It is also called recursive function. But how this recursive function executes is the same story. First, we are calling ABC and passing the value is a 3. So ABC function execute. The value 3, what you have passed, will come and store into this X. Inside that, it is printing that X value is a 3. If that 3 is greater than 1, yes, condition is true. Then we are calling ABC of, if condition is true, 3 minus 1 is a 2. It is calling with the 2. Again, it is executing ABC of X is equal to 2. And it is printing print of 2. If 2 is greater than 1, then here it is ABC of 1. And again we are calling, look at this, ABC of X is equal to 1. Just printing that value is a 1. Now observe here, if 1 greater than 1, condition false. Condition false. So if block will not execute, but that last statement followed by the if block should execute. It has to complete that function execution start to end. So that 1 it is printing again. 1 it is printing again. At start it is printing 1 and at the end also it is printing 1. Now this function execution completed. So now it will come back to here because if it is called from here, it will come back and it will close. Then here that last statement will print is a 2. Then it is closed. Now this one is completed. And again it is called from here and it will come back. It is closed. And it is printing that value is a 3. That is. And from it is called from here. It is called from here. Because whenever you are calling, program execution starts here if you want to write perfectly. So it is moving like this. First, numbers 1 and it is 2 and it is 3 and it is completed. First, last one completed 4, come back 5 and it is completed, come back 6. This is also called recursion. Recursion is also called application of stack. Application of stack because where functions execute in last in first out order, because this execution will not complete first. This is last called function, but this execution first. Then it will come back, then it will come back, then it will come back. Like this it is executing. Last in first out. Okay, this is how that recursive function gets executed. Now the same thing we are implementing using that in order, pre-order and post order. In order, pre-order, post order. So here First, let me show you that how this in order, pre-order, post order gets executed. And this is the code. Suppose it is executing. Let me just wait. From this, you need to complete that code. Sorry. Right. So this is the function. Suppose consider this is the root. Root holding that value is 1,000. So it is passing that root value is 1,000 to the function for calling. Okay. So here simply we are writing this way. Root value equals to 1,000. Root value equals to 1,000. Now how this code gets executed? This is that function in order. Whenever you are passing root, that will come and store into this P. Nothing but this 1,000. Here in order root, that P is equal to 1,000 will store. Now look at this first statement. If P2 left is there, in order P2 left. If P2 left is not equals to null. Look at the 1,000 to left. 1,000 to left is 2,000. If P2 left 2,000, yes, it is there. So then you need to call in order of P2 left 2,000. So from here, it is calling this function. It is calling this function 2,000. Now, in order P equals to 2,000. 2,000. So the question is, look at this. If 2,000 to left is there, no, 2,000 to left is null. 2,000 to left is null. So it will not execute if block. 2,000 to left is not there. So it will not execute. Directly, it will print P2 data. So what is that P2 data? Print P2 data, 2002 data 30. 30 will print in the output. Next it is checking, look at this. P2 right is there? No, right is also null. Right is also null. It will not execute. It will not execute. Only 30 will print first. So P2 left is not there and P2 data is printing, P2 right is not there. It is completed, but see, look at this. It is called from here. So it will come back to this place from where it has called. Okay, now here it is printing because look at this. Here if block completed. If block completed, P2 data it has to print 1,002 data. What is that 1,002 data? Is a 50. Is a 50. So here print 50 is printing. Then it is checking if P2 right is there. 1,000 to right, 3,000 is there. Yes. So it is calling in order 3,000. Look at this. 1,000 to right is there. Now it will come to here. It will come to here in order P value is 3,000. It will call from here. It will call from here. So in this one, it is checking if 3,000 to left is there, no, null. if block failed, print, the data will print. 3002 data is what? 70 will print. Then it is checking right is there. No, right is also not there. So it will not execute this one. So finally it is called from here and it will come back. And it will come back and it will close that here. So in output first, whenever it is going here, first it is printing 30. Then it will come back. It is printing this 50 as a second. Then it will go to here. It will print as a third. In order means what? In ascending order, 30, 50, 70 is out. Here I have just taken only 3 nodes. I have just taken here 3 nodes. Okay, that is. Got it? Yes. Now, what you have to do today with the help of this one, just try with for this case, you just try. After that, for this in order traversal, just like this, add pre-order traversal and post-order traversal and complete code you need to do it. Remember that. Then once you are good at that recursion concept, binary tree insertion using recursion, stack implementation using recursion. Next, like linked list, single linked list concept using recursion also we can do. We can implement. But recursion with recursion later. Once you have completed that, then tomorrow I will start expression evaluation concept. Prefix, infix, postfix evaluation I'll explain. Okay. I'll upload the video quickly in 2 minutes and you have to complete that code. Only one student written, remaining also complete. Do it.